The properties for integrals are similar to the properties of derivatives. One of the properties of derivatives that you learned is that if you're adding two functions, x squared plus 5x, you can take the derivative of each thing separately. So when you're integrating two functions that are separated by adding and subtracting, you can integrate them separately. So here, if I want to integrate this whole thing, what I can do is use the integral rules for each one separately. How do I integrate x to the 5? Add 1 to the exponent and divide by my new exponent. How do I integrate negative 3x? Add 1 to the exponent, divide by my new exponent. Integral of 2 would just be 2x. And then, of course, plus c. Something you might do on your quizzes and tests is as soon as you get your test, write a big plus c at the top so that you remember to add it every time you do an indefinite integral. What about multiplying? With derivatives, if you were multiplying, could you just take the derivative of each one separately? No. We had a long-winded product rule. Okay? So that means we can't integrate separately with a product. It doesn't work. Because the product rule is complicated when doing derivatives, and generally speaking, when working backwards, things get more complicated. We can't do a product rule here because that doesn't work for derivatives, but if we use our algebra skills, we can rearrange this to this binomial, or trinomial, sorry, and then we have the ability to integrate separately. So this will be x cubed over 3 plus 4x squared over 2. And notice that, you're going to notice that in the past, doing the working backwards from 4x, you would have in the past said it's 2x squared, I can do that right away. But you're going to find that you're going to get into this mode of adding 1 to the exponent and dividing, that you'll just do the process more naturally. Minus 21x plus c, where c is any real number. So for the next couple, I want to see if you can figure out ways that you can manipulate those equations. All right, let's see how you did on these next ones. Did you think of factoring? Factoring the top, then these x minus 2's, because we don't have a quotient rule for integration. And then our integral is just x minus 4 dx. Add 1 to the exponent and divide, minus 4x plus c. And for the last one, well, the last one is already separated by adding. We might just take one extra step to change the cube root to u to the 1/3. The fact that the letter is u, but the fact that it tells us du, we're fine to integrate with our normal rules. Add 1 to the exponent and divide. Add 1 to the exponent and divide plus c. So we're going to get Now the same thing with derivatives. If you have a constant, that constant doesn't affect finding the derivative. It doesn't affect finding the integral. You can pull that constant out in front and just integrate like normal. Now, why might we want to do that? Well, this first example, let f of x find the derivative first. So I'm going to rewrite f of x as 4x to the negative 3. How do we do a derivative? We bring the number out in front and subtract 1. I should have really got you to do this one first. In subtracting 1, did you correctly get minus 4? Or were you tempted to write minus 2? Okay. In subtracting 1, did you write plus c after? Were you tempted by that? Okay, so can you see some of the things that you're going to, like, yeah, it's just waiting to happen. Now, if we wanted to integrate 4x to the negative 3 dx, the 4 itself, you could pull that out in front if you wanted. It really doesn't matter. All we have to do is the integral of the x to the minus 3, which says add 1 to the exponent, divide by your new exponent, plus c. And in adding 1 to the exponent, you might have been tempted to write the minus 4. And then you're like, do I add the c this time or don't I? So here, too, I'm going to give you some time to try a couple. The 5 is a fifth root on this one. So you can do this one and try the next couple. All right, check how you did on these last couple. So again, I would start by rewriting this one. Integral of 30u to the 1/5 du. Add 1 to my exponent. (30 divided by 6/5, is that 25? Okay, do a quick check. Look, if I multiply 6/5 by the 25, I'm going to get 6 times 5, which is 30, which matches up. Yes?
You're like, write the C's and CER in the answer at all? You have to like write it again.
If I didn't write it here, do I have to write it again? No, you've defined it once. And like I said, I'm not going to be too particular. If you write plus c generally, I'll know that you mean all real numbers. Yeah. The du is from the equation, and that just tells you which variable you're integrating for. Okay? That becomes important later on because sometimes we have more than one variable in an equation. And you can integrate with one of the variables but not the other one. And yeah, but for us right now, we're always going to be integrating with just one variable. But we had some questions where we had two variables. Let's see if I can go back to find here. Here's one where I said, find the integral of y dx. Y dx, well, y isn't an x. You can't just add 1 to the exponent to divide by 2. You have to actually substitute the x's in for y in order to find the derivative. If I had asked the integral of y dy, then you could say, oh, it's just y squared over 2 plus c. All right? Some general rules. If you take the integral of a derivative, you just get the original function back. Does that make sense? If you work backwards and then work forwards, right? For example, I want you to do some mental math. Okay, I'd like you to do 73 to the power 5. Good. Now take the fifth root of your answer. Good. What do you get? 73. You cheated. None of you, if I would say I want to see your work from your head, none of you did 73 to the power 5. Right? But, yeah, I can't. I have no proof because you got the right answer, right? But same thing here. What's this say? It says take the derivative of 5x squared. d dx says take the derivative of 5x squared. Well, how do I take the derivative? Well, the 2 would come out in front, subtract 1 from the exponent. Now it says integrate. If I integrate it, what am I going to do? I'm going to add 1 to my exponent, divide by 2 plus c. Well, what's this equal to? That's equal to the 5x squared that we started with. We could have saved ourselves a lot of time just by saying those things are going to cancel out. However, there's a slight difference. If you do the derivative first, then the integral, there's going to be a plus c, because the last thing you do is the integral. If you do the integral first and then the derivative, there's going to be no plus c. Watch why. If I do it actually in the order, I'm going to get d dx of integral of this says add 1 to the exponent and divide plus c. Now when I take the derivative of this, well, the derivative says bring the negative 2 out in front. That's going to cancel out with the negative 2, subtract 1 from the exponent. And then what's the derivative of c? Nothing, because it's a constant. And so when you do the derivative last, you just get the answer. When you do the integral last, you still have the plus c. Yeah, they're both going to, I mean, you could just say right away it's going to be 5x to the minus 3 without having to show all that work. But in this case, I'd say, oh, I don't need the plus c. In the previous situation, I would need the plus c.